Hello and welcome to Engineers Mindset Academy. So in the past three videos, we've done design analysis of a rivet joint. So in this video, which is the fourth video, we are going to be looking at design analysis of a group rivet joint, as can be seen on the board. So let's use this particular question to explain the design analysis of a group rivet joint. All right, let's look at the question. Question says, a bracket is bolted to a stationary stanchion and carries a vertical load of 50 kilonewtons. Assuming that the total shearing stress in a bolt is proportional to the relative displacement of the bracket and stanchion in the neighborhood of the bolt. Question says, find the load carried by each of the bolts. Alright, so we have about 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, these are all, this is a plate which carries a rivet. So, of course, the term here is used. Of course, the term here used is bolt, but then this is a rivet. They all function or carry the same function to fasten or hold together engineering structures or members. So we are asked to find the load carried by each of these bolts. Now, this is what I will do. I'm going to redraw the diagram over there, make it more larger because I'm going to be needing spaces to do my analysis. All right. All right. So we can now start the calculation. Now, the question is asking us to find the load carried by each of these rivets. In analyzing a group rivet such as this, the first thing to do is count the total number of rivets involved. That's the first thing to do. Obtain the total number of rivets involved. So let's start. We can start with 1, 2, 3, 4, 5, 6, 7, 8, and 9 rivets. So the number of rivets, the first thing, number of rivets n is equal to 9. This is the first thing to do. Obtain the total number of rivets involved. The second thing to do is select the middle rivet or the central rivet to be the reference point. Select the central rivet to be the reference point. So in this case now, rivet 9 is my reference point, which is the central rivet. Rivet 9 is my reference rivet or reference point. 2, rivet 9 is reference rivet. Okay. Rivet 9 is the reference rivet. Now, step 3, the third step is simply draw a line from the center of all the rivets to connect to the center of the reference rivet. So it means that this is the center of this rivet. I have to connect all the rivets from the center to the reference rivet. So from here, I will have something like this. Okay, from here, I will have something like this. From the center, connect all. Okay, from here, I will have something like this. Forgive me, my diagrams might not be too accurate. From the center, I will have something like this. Okay, whereas the other rivet by the side, from center as well, remember, it must always be from center. So from the center, I will have something like this. From the center, I will have something like this. From the center, I will have something like this. From the center, I will have something like this. So draw a line to connect each of the rivets from their center to the reference rivets. That's the third thing to do. The fourth thing to do is find the weight per unit rivet. Okay, find the weight per unit number of rivets. So you simply have weight all over n, W divided by n, where the weight is the load carried by the rivet and the load in this case is 50 kilonewtons. So you simply find 50 all over the total number of rivets. Total number of rivets n is equal to 9. So 50 divides by 9. Let's see what we are going to obtain. 50 divides by 9. That simply gives us 5.6 kilonewton. Okay, so 50 divided by 9 simply gives us 5.6 kilonewton. So this simply means that the weight carried by each rivet is simply what? 5.6 kilonewtons. Now, this weight per unit rivet will cause a direct shear force which acts vertically downwards from the center of each of the rivets. Take note now, this weight per unit rivet will have a direct shear force which acts vertically downwards from the center of each of the rivets. So from each of the rivets, from here I have a weight which acts vertically downward. I have a load which acts vertically downward, and the value is equal to what? 5.6 kilonewtons. So this is 5.6 kilonewtons on each of the rivet except the central rivet, mind you, except the central rivet. So 5.6 kilonewtons. Same thing here from, okay, 5.6 kilonewtons on each of the load vertically downward on each of the rivets. So we have 5.6. Okay, I can keep this here. I can keep this one here, 5.6 kilonewtons from the center of each of the rivets. This load carried per unit rivet is simply acting, causing a direct shear stress which acts, a direct shear force which acts vertically downwards. Okay, so we have each of them 5.6 kilonewtons acting vertically downwards from the center. We have 5.6 kilonewtons from the center. We have 5.6 kilonewtons. Okay, of course, this is also going to be acting vertically downwards, 5.6 kilonewtons, and we have this. All right, I think I can wipe here. So please keep the question in mind. We are to find the load carried by each of the rivets, individual rivets. We are to find the load carried by each of them. Now, the fifth thing to do is to find the eccentric moment. The fifth thing to do is to find the eccentric moment. Number 5, calculate the eccentric moment. Okay, now what is the eccentric moment? It is simply the moment of the load carried about this neutral axis or the central axis. So simply this load carried, total distance it takes to get to the center is 22.5 millimeters. So you find the moment of the load about that central axis. So it's simply called eccentric moment. So moment is equal to the load W times E, where E is the eccentric distance or distance about the central axis from where the load is found. Okay, so moment is equal to the load itself is 50 kilonewtons. Okay, 50 kilonewtons multiplied by the eccentric distance is 22.5 millimeter. So you can as well convert that to meters. This becomes 22.5 by 10 to the power of minus 3. And not forgetting, kilo simply means by 10 to the power of 3. So let's convert all at once. So this becomes 50 by 10 to the power of 3. Okay, multiply 22.5 by 10 to the power of minus 3. Let's obtain the moment, eccentric moment. That simply gives us 1125 newtons meter. Okay, 1125 newtons meter. So this becomes the eccentric moment. Now take note now, this moment will cause a secondary shear force which acts perpendicular to the lines connecting each rivet to the center. This moment will cause a secondary shear force which acts perpendicular to the line connecting each rivet to the center. So this simply means that this value obtained 1125 newtons meter will cause a secondary shear force. It must be at 90 degrees to each of the lines connecting the rivets, each rivet to the center. For instance, this is a line connecting rivet 7 to the center. This is a line connecting rivet 7 to the center. At 90 degrees, we'll have something around here at 90 degrees. Okay, let me take this off a bit. 5.6 kilonewtons. All right, so at 90 degrees, we have this. So this is now the secondary moment, and we'll have the value to be 1125 kilonewtons. Okay, this is the line that connects this rivet to the center. At 90 degrees could either be upwards or it could be downwards, whichever you choose. But let's take it downwards for this particular rivet. Okay, so we have it somewhere around here. The value still remains 1125 kilonewtons meter. This is the line that connects this rivet 1 to the center. At 90 degrees could either be here or it could still be somewhere around here. So we can have it here. Okay. At 90 degrees should be here. So we have 1125 kilonewtons meter. Similarly, this is the line that connects this to the center. That means at 90 degrees should be somewhere around here. Now, we are going clockwise, or you can go anti-clockwise, which is why we are going following this manner. Okay, so if you're going anti-clockwise, you can take everything the other way around. All right, so this is the line that connects this rivet to the center. At 90 degrees, you have it to be here. So which means this is 1125 kilonewtons. Similarly, this is the line that connects this rivet to the center. At 90 degrees, you have it somewhere around here. So this is 90 degrees to the line that connects it to the center. So you have it here. This is 1125 kilonewtons. This is the line that connects this rivet to the center. 90 degrees will point upward. So let me take this up a bit. Okay. 5.6 kilonewtons. All right. Now 90 degrees will go upwards. Now, okay, and the value is 1125 kilonewtons. Okay, kilonewtons meter. All right, kilonewtons meter. Kilonewtons meter. Okay, kilonewtons meter. Please correct all of that. Kilonewtons meter, kilonewtons meter. Okay, we have this. Similarly, this is the line that connects this rivet to the center. So at 90 degrees should be somewhere around here. Okay, so you have it to be here. Mind you, this can be confirmed. This is 90 degrees. All right, so 90 degrees will be somewhere around here, which is 1125 kilonewtons meter. Whereas this is the line that connects this one to this rivet to the center. Okay, this is the line that connects this rivet to the center. 90 degrees should be somewhere here. This is 90, as can be confirmed. Okay, so 90 degrees is pointing this way. So we have the value to be 1125. This is rivet 7 kilonewtons meter. So you have something like this. Okay, so the moment due to eccentricity causes a secondary shear force which acts at 90 degrees to the line connecting each rivet to the center. So you have this. So on each rivet, we have two shear forces. One is force due to the weight carried per each of the rivet, or weight carried per unit rivet, and second is the eccentric moment which acts at 90 degrees to each of the lines connecting each rivet to the center. So you have some. So by 90 degrees, I simply means this line, okay, is the secondary shear force. This is the central line. Observe that this to this is 90 degrees. Similarly, this line is the central line. Observe that this to this is 90 degrees. Similarly, this line is the central line. Observe that this to this is 90 degrees. So they must always be at 90 degrees to the line connecting them to the center. And they must be either clockwise or anti-clockwise. So you can't go the other way around. They must either follow clockwise or you follow anti-clockwise. That is the fifth step. All right, so after this step now, the next step, which is the sixth step, the sixth step is to find the total distances of each rivet about the central rivet. The sixth step is to find the distances of each rivet about the central rivet. That's the sixth step. Okay. Sixth step, distance of each rivet about the center. So notice that rivet 8 and rivet 4 takes equal distances to get to the center. Rivet 8 and rivet 4 takes equal distance to get to the center, which is simply what? From here to this point, covering this distance 50 millimeter. Similarly, from here to this point, covering this distance 50 millimeter. So which means rivet 4 and rivet 8 have the same what? Number of distances. All right. Also, notice that rivet 6 and rivet 2 also take the same distances to get to the center. From here to this point, covering this distance 75 millimeter. From here to this point, covering this distance 75 millimeter. So rivet 2 and rivet 6 also goes through the same distance to get to the center. Similarly, rivet 1, rivet 1, okay, rivet 1, rivet 3, rivet 5, and rivet 7 also takes equal distances to get to the center. But this distance is what? Diagonal to get to the center. So we need to find what? The value of this diagonal. Because we are only given these sides, we aren't given the diagonal. So what you do is pull out one of the rivets. Pull out one of the triangles formed by the rivets. So you can pull out rivet 2, 3, and 9. Okay, pull out rivet 2, 3, and 9. So you have something like this. Okay, this is rivet 9, which is the central rivet. This is rivet 3, and this is rivet 2. Remember, from rivet 3 to rivet 2 is 50 millimeter, which is from here to this point, 50 millimeter. So from 3 or from 2 to 3 is 50 millimeter. Whereas from 2 to 9, from 2 to 9 is this height, which is 75 millimeter, as can be seen there. So this is 75 millimeter. So which means in order to find the distance between rivet 3 down to rivet 9, we need to employ what? Pythagoras theorem. So from Pythagoras theorem, we have the square root of 50 all squared plus 75 all squared. The sum of the square of the two adjacent sides. So you simply have this, and this is equal to square root of, let's obtain 50 squared plus 75 squared. That gives us 8125. So take the square root now. That simply gives us 90 millimeters. So which means rivet 3 to rivet 9 is actually what? 90 millimeter apart. So this diagonal axis remains 90 millimeter. And trust me, it is still the same distances apart. Since their sides are the same, 75 and 50, it means this also takes 90 millimeter. Okay, and this also takes 90 millimeter. This also takes 90 millimeter. You have this. So it means now that rivets 1, 3, 5, and 7 has total distance of what? 90 millimeter about the center. Rivet 2, okay, rivet 2 and rivet 6 have the same distance about the center. Rivet 2 and rivet 6 takes what? 75 millimeter to get to the center. So you have 75 millimeter. And rivet 4 and rivet 8 take equal distance to get to the center. This is rivet 4 to the center, rivet 8 to the center, covering what? 50 millimeter. You have 50 millimeter. So this is the sixth step. Identify the distance of each rivet about the center, which is what we've done so far. All right, guys. So in summary, the step 6 simply says determine the displacement of each rivet about the central rivet or about the center. So this is a summary of the distance of each rivet about the center. So rivet 1, 3, 5, and 7 have the same distances about the center, which is 90 millimeter, and that's 0.09 in meters. Rivet 2 and 6 have same distances. This is rivet 2 and this is rivet 6. Their distance to the center remains 75 millimeter, which is 0.075 in meters, and rivet 4 and rivet 8, okay, about the center maintains the same distance, 50 millimeter, which is 0.05 in meters. The seventh step is to find the sum of the square of the distance of each rivet about the center. So you find the sum of the square, okay, of the distance of each rivet about the center, okay, about the center. So we simply use this notation, summation from I equal to 1 down to n r squared. So we are simply looking for the sum of the squared of the distance of each rivet about the center. Now, we already know that rivets 1, 3, 5, and 7 have the same distances about the center. So instead of picking these distances individually for each of the rivets, since this totally makes up 4 rivets that have the same distance about the center, rivet 1, rivet 3, rivet 5, and rivet 7, total of 4 rivets, you simply have 4 times R1, 3, 5, 7 all squared, which means the square of the total distances of these 4 rivets multiplied by the total number, which is 4. Okay, plus we have for rivet 2 and rivet 6. This is actually two rivets following the same distance to get to the center. So it becomes 2 times r2 6 all squared, plus finally rivet 2, rivet 4 and rivet 8 also taking the same distance to get to the center. It becomes 2r4 8 all squared. So let's obtain this value now and see. This is going to be equal to 4 times rivet 1357. Their distance apart is what? 90 millimeter to the center, which is 0.09. So you have 0.09 all squared plus 2 times rivet 2 and 6 takes 75 millimeter, which is 0.075. So you have 0.075 all squared plus 2 times rivet 4 and rivet 8 takes 50 millimeter, which is 0.05. So you have 0.05 all squared. Okay, so evaluating this all together, you're going to have that the summation of these total distances, okay, is going to be okay, so you can punch this as well, because I'm punching all together. You can punch this all together as well to confirm the result, but the result is simply 0.05 in meters squared. So this becomes the sum of the square of the entire of the distance of each of the rivets about the center. All right, so you have it to be 0.05 meters squared. Now, after obtaining this, the eighth step is simply find the moment of each of these rivets about the center. Okay, find the moment of each of these rivets about the center, and you all know that moment is simply force times distance. So it means that the moment of rivet 1 should be force 1 times distance it takes to what? Get to the center. Moment of rivet 2 should be force 2 times the distance it takes to get to the center. But in order to obtain this moment, there is a very tricky approach which we use. So I'm going to show you over here now. I'm going to show you that now. Okay, so we can do that here. I think we can do that from here. Let me just, all right. Now, to find the moment of each of these rivets, you simply make use of a very simple equation. The equation is this: force all over distance. Now, this is force for any of the rivets all over distance of that same rivet multiplied by the sum of the total distance of each of the rivets, which is summation from I equals 1 to n times r squared. Now, why is it so? Now, if arrow, which is a meter, arrow cancels one of this arrow, it means I am left with what? Force times just one of this arrow here. And this arrow signifies distance from what we've done here. It signifies the total distance of each rivet about the point of the central rivet. Okay, so this becomes force times distance, and this is going to be what? A moment in newtons meter. Okay, so this is obviously a moment in newtons meter. So this is how you solve. It becomes force, the particular rivet you're referring to, all over the distance of that particular rivet about the neutral axis, multiplying by what? The sum of the total distances. So which means that for this case where I have rivet 1, 3, 5 and 7 having the same distance about point the neutral rivet or the central rivet, there is no need to start picking out f1 over r1 times this or f3 over r3 times this, because the distance about the central rivet is what? The same. Since they are all the same, it simply means that for the first case, I'm going to have f1, 3, 5 and 7 all over r1, 3, 5 and 7, because this rivet takes the same distance to get to the what? Central rivet. Therefore, the same intensity of force will act on them. Okay, now if this multiply by the sum of the total distances, summation from I equals 1 down to n times r squared, then we have a moment in the first case. All right, so we can do that at once. Now, this is simply equal to f1, 3, 5 and 7 all over the total distance it takes this rivet 1, 3, 5 and 7 to get to the center remains R1357, which is 90 millimeter, and we converted that L to the 0.09 times, we obtain this summation of total distances to be what? 0.05 in meters squared. So remember, this is 0.09 in meters times 0.05 in meters squared. So observe that meters cancels one of these meters. So what I have here now becomes what? 0.05 times F13, which is 0.05 F1357 divided by 0.09. Okay, so that means this moment will simply be, now we need to obtain 0.05 divided 0.09. That simply gives us 0.056, and hence this simply implies F1357 all over R1357, okay, times and summation I equal to 1 R squared simply gives us 0.56 F1357. So we have this. Now, the same thing is applicable for F26 all over R26 times summation I equals to 1 down to NR squared. It's still the same formula. So the moment for the rivet 2 and rivet 6 becomes now F26 all over R26 is the distance between rivet 2 and rivet 6, which we obtain here to be what? 75 millimeter, and that is 0.075 multiplied by the total distance, which is 0.05 in meters squared. Okay, now this is going to now be what? 0.05 times F26. Okay, so let's just do all at once. It becomes 0.05 divided 0.075. So let's obtain the value 0.05 divided 0.075. So it gives us 0.67 F26. Now this is a Newton's meter because it becomes now a moment. This is a Newton's meter because it becomes a moment. Finally, for the force of rivet 4 and rivet 8 all over distance rivet 4 and rivet 8 times and summation I equals to 1 R squared. This is going to be F48 all over the distance between rivet 4 and rivet 8. This is rivet 4 to the center, rivet 8 to the center is what? 50 millimeter. So remember, we converted that earlier to be 0.05 in meters multiplied by this summation. Total distances gave us 0.05 in meter squared. So meter cancels one of the meter, 0.05 cancels 0.05, so I'm left with what? F48. So this is simply equal to F48 in Newton's meter. All right, so we found the moment of each of the rivets about the center, moment of each of the rivets about the center. The final thing is employing now your equilibrium equation. Under equilibrium condition, the moment of each of the rivets about the center is equal to the eccentric moment. Under equilibrium condition, the moment of each of the rivets about the center is equal to the eccentric moment. So this simply implies that the first moment, which is 0.56 F1357, is equal to the eccentric moment. Similarly, the moment between rivet 2 and rivet 6 is also equal to the eccentric moment, and so on. So let's start with the first. 0.56 F1357 equals 1125. So this simply implies in order to find the force 1357, it means we divide 1125 by the coefficient of that force, which is 0.56. So this is going to be what? Let's obtain that division. 1125 divided 0.56. That simply gives us 2008.9 newtons. Hence, the force. Now, since this is force 1, 3, 5, and 7, and the rivet 1357 takes the same distances or takes equal distances to get to the central rivet. This simply implies that F1 is equal to F3, and this is equal to F5, and this is equal to F7, and the value remains 2008.9 newtons. Okay, so this is force between rivet 1, rivet 3, rivet 5, and rivet 7. Similarly, F26, the moment of rivet 2 and rivet 6 gave us 0.67 F26. So you have under equilibrium condition 0.67 F26 is equal to the eccentric moment, which is 1125. Therefore, to make F26 subject, okay, F26 becomes now 1125 divided by the coefficient of F26, which is 0.67, divide 0.67. So this simply implies that F26 is equal to, let's obtain that division, 1125 divided 0.67. That gives us 1679.1 newtons. Okay, that gives us 1679.1 newtons. So this simply means that F2 is equal to F6 and the value is 1679.1 newtons. So force 2 and force 6 are equal and their value remains 1671 newtons. And finally, to find force 4 and 8, the moment of that force or the moment of rivet 4 and 8 must be equal to the eccentric moment. And the moment of rivet 4 and 8 left us is what? F48. So we have F48 to be the moment, and it must be equal to the eccentric moment, which is 1125. So we have 1125. Okay, we have 1125. So which means automatically the force between rivet 4 and 8 is simply 1125 Newton. So this simply implies that rivet 4 has a force equal to rivet 8, and the value of that force is simply 1125 newtons. All right, so these are the individual loads or the individual force which acts on each of the rivet according to what the question is asking us to find. Now, you might also be asked to find the magnitude of the load carried. In that case, it's very simple. Okay, I think I'll skip that for the next question. Maybe in the next question, we can talk about situations where you're asked to find magnitude of the load carried by the rivet. All right, guys. So I hope this actually helps you to understand group riveting. I will see you in the next video with more questions. If you're new to the channel, please do well to, of course, subscribe to the channel and turn on the notification bell for updates when videos like this drop. I will see you in the next video. Thanks and cheers.